again from Berkshire Guitar Amplifier Repairs in Reading, England. I've been posted an interesting little amp today, which I think I'll show you. It's called a Phaez. I don't know how you pronounce it. P-H-A-E-Z. I've never heard of them. And it's a little, let me show you that there. It's a chassis that he's posted. The valves are out. Bit of hardboard on the bottom to protect it. And he says he hasn't used it for a couple of years, and when he fired it up recently it started to make a humming noise even with no instrument cable plugged in. So it's a hum chaser again. I've been doing a lot of amplifiers recently which have had hum problems. Anyway, let's get the bottom off, have a look inside. I have no idea what this amp is or what's going on with it. I thought it would be an interesting one. I'll never see one again. I'm sure you will never see one again. So let's have a look inside and see what makes it tick. Right, you're seeing this as I'm seeing it. The valves have been taken out and packaged up separately. It says 3 12AX7s. I'm pretty sure there aren't 3 12AX7s in here. In fact, there aren't. Okay, we've got a couple of KT66s. It does say 12X7 times 3 on there. Oh, let's have a quick look. Oh yeah, maybe there are. Right, so there's the valves. No, that's a maker valve I've never heard of. Baldwin? Ever heard of a Baldwin preamp valve? I never have. That's got an unmarked one. Got a bit of a motley selection here. And some other strange piece of junk. What a weird selection of valves. I might try to persuade him to have a new set of preamp valves at least. Right, so, well, what have we got? Mains transformer, output transformer, nothing much to see on top. There's the front. It's all very homemade, look. These are just kind of dymo taped on. Not sure whether he built this himself or what. Okay, I think this may possibly be just a temporary piece of wood for shipping. I can't imagine that that's supposed to be like that, but anyway, I'm pretty sure that's what this will be. Who knows though, who knows. It's got these feet on as well, so maybe this is as he wants it. 2 of the feet came off in transit. I'll be here all day with this. The screws are about a foot long. Good Lord. Good grief. Do you reckon that's long enough to hold that piece of hardboard on the bottom? I don't know. I think I might get another 6 inches on that. Bonkers. Reef. Right, oh well, interesting. It's got a printed circuit board which I didn't expect. Let's see if we can, it doesn't stand up on its. See if we can get this standing up a bit more sensibly. Ugh, a horrible unbalanced thing. Right, so we've got a PCB which, what a weird system. PCB which isn't really doing anything particularly, because all the, you may as well just have valve bases here if you're going to do this stuff. Of course we don't have a schematic. Tiny little HT caps. This must be a very low power. It's got a pair of KT66s, isn't it? That kind of implies it's 50 watts at least. Excuse me folks, am I being stupid here? If this is a 50 watt amp, where are the decent HT caps? We've got these two poxy little things here, 68 microfarads at 500 volts and 47 microfarads at 500 volts. Well, okay, I'll believe them, but that's half the size of a cap that I would put in a, you know, a radio, an axial cap I would put in. You've got these cheap and cheerful things here as well, which are also 10 microfarads at 450 volts. Well, there's nothing obviously wrong with it, so I think we're going to have to power it up and have a listen and see if we can get a feel for what's going on. Let's get some valves in it and see what it does. Okay, moment of truth. You're seeing this as I am. I've put the valves in. I'm suspicious of these whacking great big KT66s in here. Was that what it was originally designed to have? I don't know. None of this looks man enough for a 50 watt amp to me. Anyway, let's plug it in, turn it on, and in standby. I'll put a speaker in. Go. So let's see if it powers up. Yeah, there's a, well, the lamp has come on the front and an immediate quite loud hum out of the speaker. I wonder if that's the hum he's talking about. Anyway, let's let it warm up a bit. The HT's not even on at the moment, so whatever hum that is nothing to do with the valves. The valves aren't even warm yet. Let's take that standby and see what happens. Not a lot. Oh, it's working. Okay, well, that works alright. Bit of a scratchy pot that, but that sort of scratchiness, where you've got a continuous scratch all the way around the pot, is not usually a dirty pot. It's usually DC on the pot, which means that the coupling capacitor for this pot is leaky. So let's see. It sounds quite nice though. I'm going to take the camera off the overhead so that you can hear this hum and see what you think. Okay, there's the hum with the amplifier on, but in standby. I would call that kind of unacceptable. It's not deafening, but it's not particularly nice. And when I put it into standby, out of standby, in other words, turn the amp on, you listen. Up comes the amp, and also that hum has receded into the background a bit. Let me put it in standby again, and you can hear the hum there. Out of standby, yeah, there we go. Okay. Right, well, interesting one. Right, you won't be able to hear the hum now, I can, but as I was moving the chassis around I heard a lot of racket going on, so I think we've got another problem here. It's very microphonic. Slightest tap on here. Try the valves. Yeah. Oh, some of these valves. That middle one is very microphonic. It's not related to the hum though. We have two problems here. Well, I seem to be getting a lot of amplifiers in with hum. I've just made 3 videos in a row of chasing difficult hum. I think they'll start calling me the Hum King. Here comes the Hum King. Well, I think I'm going to do what I did on the other amps and get myself a really thick cable and see if grounding various things causes the hum to ease. Right, well what I'm going to do is I'm going to go on to, I've got to be a bit careful here with this lead. We've got a ground here which is going to these jacks. So I think I'm just going to try grounding that to chassis and see what happens. No change. No. Cool, that is really kicking off now, that valve. So I'll go to the ground here and to chassis. No change there. There's another ground here. Let's try that to chassis. No, nothing. Well, let's go over here. Oh, that's interesting, that's quite hummy. There's a steady low level 50 Hz hum there. Do you know what? I've just had a kind of thought on this. This mains transformer is smack up against the output transformer. This hum is there with no input in, it's not affected by any controls, and so in my view it's not a hum loop problem in that sense. It's in standby, the amplifier, so there's not even any HT. I bet you a tenner that if I pull the output valves out, in fact, I'll tell you what we can do, we can pull all the valves out. So let me just flip this over and show you what I'm thinking. Now, look at the proximity of the mains transformer to the output transformer. Could it be that the output transformer is quite simply picking up hum directly from there? Well, we can pull all the preamp valves out. Hasn't changed the hum in the slightest. I bet you anything, if I pull the power valves out, it doesn't change the hum. It doesn't. Right, so we've got no HT, no power valves in, no valves of any description in this amp, and it's humming away exactly the same as I showed you on the speaker. Right, I'm going to get a piece of steel and just put it down between here and here just to see if I can hear any hum reduction. The customer said, I think he said, he had changed the orientation of the output transformer just to see if that had affected it. I think it was this customer who did that. Anyway, let me get a piece of steel. Well, it's a huge piece of steel, I don't seem to have a small piece, but I'm just going to put this in here. I'm just listening very carefully. I'm sorry you won't be able to hear this. It's quite low level. Yes, that reduced it by, this piece of steel reduced it by 50%. So I'm 100% convinced that this is direct pickup from here to here. So the hum's always been there. Now what I will do is, I think I'll take this output transformer off. And hopefully we'll be able to get a bit of movement in it to at least move it away from here to prove the point. Then we might also get enough movement to reorient it. So let's do that. How is it held in? So I'm going to take these 4 screws out. There's not much play unfortunately on, in fact there's virtually no play on this, which is a pity. We'll be able to orient it though, turn it round. Okay, I've had a word with the customer and he drilled these holes here and he did try orienting the output transformer 90 degrees from its current position, and he said it had no effect, which is really surprising. I would absolutely expect that to have some sort of effect. So what I'm going to do now is I'm going to extend all of the leads of the output transformer, take it out, and then we can 100% definitively prove that moving away from the main transformer kills the hum. I will also, of course, then try the 90-degree trick, and then we'll take it from there. We don't have a lot of options here. The transformer, no, it can't go any further that way, so we've got no other options about where to have the output transformer. If none of that has any effect, then I've done it in the past, although it was many years ago. I could make up, well, obviously we can make up a very thick steel sheet, you know, some decent steel plate to go between these two. Or you can buy stuff called mu metal, MU metal, and that is specially designed to prevent exactly this problem. And we can make up a mu metal shield. I haven't bought any for 25-30 years, so I've got no idea where to get it these days, but I'm sure you can get some. And we'll put a mu metal shield in there, and it will certainly reduce it. The very worst we can do with this amp is kind of reduce it by 50%, and that will probably make it usable. So let's crack ahead with playing around with this output transformer now, and the first thing we need to do is to extend these leads, because we've got no play at the moment on any of this lot, so we can't. These are really tight, and these are tight here on the speaker outputs. So I'm going to make a note of all these wires, and then we'll just extend them. I won't make you watch me do that. I'll rejoin you when it's all extended and we're ready to play. Quick progress report. I've extended the primary of the output transformer, so the blue bit of insulation to there, the purple to plate 1, the green to plate 2. So we've done that. Now we just need to do the secondary, which is basically the tappings for the speaker: 4 ohm, 8 ohm and 16 ohm. 4, 8, 16 and ground. So I'm just going to make a note of those, and then we'll do the same with that. Okay, I've done the secondary side now. All I've done is extend the yellow wire and the black wire, so that's ground and 8 ohms. I don't need to extend the 16 ohm and 4 ohm tap. I'm just going to leave those floating. So this is the feedback resistor here, I think. I'm just going to put that there. I do know where that goes. So now I think the next thing to do is, before we do anything, we're all safe here, is to turn it on again and see, but just make sure we've still got the hum. Nice and loud, nice and audible. That's great. So the next thing I'm going to do is to take out the output transformer. It's coming down now. That's fine, it's about 75 volts, that'll be alright. Turn it off anyway. Right, I've got quite a large collection of nut spinners, but not one that will fit that, which is annoying. So let's see what the screws are like, if they will come undone. That one's loose already. That one's loose. That's okay too, which means we can just get some pliers on the other end of these and undo them. Yeah, they're all loose, that's good. Alright, I won't bore you with this. I will just take the output transformer out, and then we can start playing around with it to see what happens to the hum. Okay, it's taken a while for us to get to this point, but now the transformer is loose and extended. We'll turn it on. The hum is still loud. Now I'm just going to rotate it if I can. And he's absolutely right. That does not improve it. Let's see if we take it closer. A lot worse. Further away. 0. Nothing there either. So that's one possibility. We could, I don't know, no, it's coming back now as we move in here. It's virtually 0 there. So that's how we mount it, I think, like that. Ha ha. Very bad there, close up to it. it doesn't get significantly better moving it away further. Pity. Right, I've freed up the transformer now and brought all the leads through so we've got a bit more play. Loads of hum there. Worse there. Better the further away you go. Nothing over here. So it's definitely pick up between the two. That's better. That's about 50% down there. But that's... it can't go there, I don't think anyway. It could just about. It's worse there than there. That's not too bad there actually. That's much worse. So there is good. Very good. It gets a lot worse when we come down here and up there. But in the middle of there, that's actually not too bad. So if we can get the transformer in here, I'm sorry I can't hear this. I can tune the hum, but it's very faint, so you won't be able to. That is perfectly acceptable, that position there. There. No hum whatsoever there. Isn't that interesting? Okay, so what I'm going to do, I'm going to mark through, so we're in luck here. Just have to double check that we can get valves in and stuff. Let's just see. Yeah, that's okay. Might just come a hair down that way. We've got some work to do here to make this happen. Right, so I've marked through here, and of course this is right where one of the screws for the transformer needs to go. So what's happening under here? Okay, so these are under the board if we start to go that route. Pity. Okay, I have a cunning plan. This is where we want the transformer located, here, here, here and here. We've got a gaping great big hole there where one of the transformer bolts should go. And these two would be under the printed circuit board. And I've had a look and it's a total nightmare to take out that board. I don't really want to do that. So what I'm going to do is I'm going to make a platform like this. Space it off by not very much, just a 3 or 4 mil. Bolt the transformer down here and here, so now we can bolt underneath the look. And then we will bolt this to the chassis via the original holes here, here, here and here. And some spacers, so 1, 2, 3, 4. Right, we're making slow progress but steady. I've made up this plate now and got the holes, I hope, in the right position. So it's 4 holes to pick up the holes here. And 4 holes for the transformer, which I haven't checked yet. Let me just check that that actually does line up okay. Yes, that's okay. So we're going to, the plan is to bolt the transformer to here, I think. And then we have to work out how to space this off. The only difficulty I'm imagining is how we're going to tighten these 2 bolts here. We're not going to be able to get a screwdriver in here. We may just get lucky in it, and with a kind of a lock nut washer on the other side it might just tighten up from the other side. But anyway, let's not concern ourselves about that. What's next? Oh yes, we've got to get the cables out. So we're here now and we need these cables to come out, so I'm just going to mark where they are. Well, okay, actually no, I need to rethink this. So basically this is going here, and here are our cable entries here and here now. I've taken the grommets out from from these two. So we're here now with the cable, which means we're going to need to route them back from the transformer and down here. That's okay, that's no difficulty. There we go. So we can just offer this up like this. Let's double check. Yeah, that's correct. So it's there. So this is where our cables need to go down here on that side. How far in? Well, I think we'll just put a hole here. That'll do. Yeah, that's fine. And then on the other side, it's just the other side, of course. So we're kind of here. Yeah, we're going to put a hole here. So that's where our cable entries are going to go. So that's the next thing to do. Okay, we've drilled some holes now for the cables to go through, and we're kind of ready to assemble. Now, what's the best order of doing this? Yes, we have to put these two bolts in and then the transformer on top. So let's see if we can find the right bolts for this to start with. Of course, but I've got a little bit lucky here because, of course, I need to space this off. So what I can do is space it off with a couple of nuts like this. One there. I might do it with two nuts on each one. It's a bit rusty, that. I hope that's okay. Yeah, that's right, yeah. And now, of course, we can do these up tight. And that will just now sit in there like that, as indeed it does. That's no, right, that's great. This kind of being designed on the fly, in case you hadn't noticed. So we may as well do these up fairly tight now. And now, do I have another two of those bolts? Well, that'll do for one. That. Right, let's see if that fits. See if my measurements were correct, because these holes aren't square, they're just relatively random. Not bad. This one here is a little bit misplaced, so I need to file this out down that way a bit. How's that? Pretty close, but we don't want interference fits here. Let's take a bit more off there. Right. It fits. Just a little bit tighter than I would like it. There's no need for it to be quite so tight as all this. Whew. Right, might have a slight problem with this one here since it's above that jack, but we'll have a look in a moment. Right, so there you go. That goes on there. Oh, of course, we're also going to have two nuts on here, so we need to come up a bit more still. I quite like this sort of work because it's inventive and creative and you know, not at all routine. Any kind of designing stuff on the fly as well, which is quite fun. If it works, it's fun. Right, that fits very nicely. Look at that, that's great. And our transformer look is going to go on there, like a so. These cables are, okay, we've got a little bit of problem with the cables. Yes, alright. There's not much clearance between the bottom of the plate and the cable entry. So we can just, of course, if we want to, we could bring this up a bit more like that. And that will allow us to get the cable through. It'll be a bit tight getting those cables through. You can see that these holes are a bit closer together than these holes, but I think we'll be right there, but we will need to bring this up a bit more to clear. So I'm going to put another 2 nuts on each one. That will also help with the amount of bolts sticking through into the chassis below, particularly with this one here, which is above that jack socket. My only slight worry about this is I'm going to have to ship this back to the customer, and normally an amp wouldn't be subjected to any kind of shock loads or anything like that at all unless you dropped it off the top of a stack or something, but with this thing going through the post, I'm going to have to really carefully pack it so that you know, this doesn't shear off with the weight of the transformer or something like that, because this will get a hammering in the post. They do not care. Alright, so now we're there. Look, that's good. And we have room for our cables to go through and feed down through there. Great, so the next thing we can do is to put the transformer on, and I think I'm going to extend these cables. They're very short. I'm just going to properly extend all of the cables. I think I'll do that. It doesn't really matter whether I do that now or later. Let's get the transformer on. I'm getting close to packing up for the night anyway. It's 8 o'clock at night. I've been on this quite a long time. But let's see what we've got in the way of smallish. These little hexagon bolt ones are quite nice. Let's see how we get on with a couple of those. Onto there. Shake proof. And then of course there's plenty of clearance now, look, with this bolt for here. That's good. Put it on that. Yep, good. And still have one more of those nice little hexagon bolt things. A nuisance if I don't. Only used for aesthetic purposes. Oh yes, one more. Great. Where are we? Here. Good. So I will do those up tight off camera. I'll get myself a nut spinner. But before I do that, have a look, see where we've got to. That's the assembly, and it sits in this way around. And now like that. How's about that? It'll be nice when that's bolted down. I've got some packing and stuff around this when I ship it. And extend the cables. Yeah, we're looking good here. I suppose we ought to have a little look underneath. I haven't done that. That's a bit naughty of me, just to make sure that yeah. So 1, 2, 3, 4. No problem at all. We can get bolts on there, easy peasy. So that's great. Good. Right. What I'm going to do now is do up these tight. These 4. And extend these cables. I'm going to put some sleeving on these cables here because we haven't got a grommet in this hole here, so I'm going to put some heat shrink sleeving all over these so that protects it going through that hole there, and similarly this side here, of course. Good, getting there. Well, I don't know when to quit. I've decided to push on, and I've extended all the cables. Look, I didn't have any thick green and thick purple, so I've just doubled up on them. That'll be perfectly okay. And on the secondary side, again, I've doubled up on the yellows, blacks. I did have some red, and the greys, so that's all ready. And I found some nice kind of heat-proof sleeving here, so I popped a couple of bits of those through there. So now all we need to do is to thread all this lot through here and hope that we can guide it down into the grommet hole there. And what about here? I think these should all go through okay. Ooh, need 2 yellows. Okay, that's that, and now what we will do is guide them down through here. Like so. And here, I'm definitely going to stop after I've got this in and ready to do the nuts up tomorrow morning. I won't do it now. Getting tired. I'm a bit silly really, I push myself too much. Right, so that's all goes in there. There we go, that's sitting there quite nicely. I'll probably try and pull these leads through a bit more. There we go, I've managed to get quite a lot on the primary side there. It's this secondary side that's a little bit crowded. Okay, I had to tart around with this quite a bit to get that to fit, but anyway, that now all does fit quite nicely in there now and doesn't look too bad either. So I'm quite pleased with that. I haven't put the bolts on yet, I'll do that tomorrow. I am definitely quitting now, and I think that's job done on that. Very pleased. Right, good morning, another day, another dollar. We can now put the nuts on to hold the output transformer in place. Okay, that's 3 out of 4, and as I suspected, this one's going to be tricky. There we go, and I'll just find a little spanner to do that up with. There we go. Now what we need to do is connect this up according to my diagram here. So let's make a start on that. Okay, the green goes to the plate of this second valve here, 1, 2, 3, pin 3. That off. Keep them reasonably short, there's no point in having acres of lead around here. The next person in here is going to say, I wonder why he used 2 pieces of wire there instead of one. It must be some exotic audio clever trick. Little do they know. That's the green. The purple goes to here. Good. And the blue is the centre tap. And I've forgotten where that went. I think it went, oh yes, went up to the HT switch here. I've left the blue dangling there. Right, let's now do the secondary side, and doesn't really matter what we start with. Why don't we start with black, which is the ground, if I remember. Black, black, black. Yes, goes to this bus bar here. I'll bring this under here, somewhere here. It's quite a big heat sink on this bus bar. Better. Good. What else have we got? Yellow. May as well do those whilst I can see it. And that goes to the 8 ohm output. Good. What else have we got? One needs to go to here, which is 16 ohm, and that is the grey. So the greys go here. Good. And there's just one left, which is this red, which I'm assuming will be the 4 ohm. Let's have a look. Red is 4 ohm, yes. So it's going to go into there. I said no anyway, but anyway, there you go. Right, so that is all done. So we're actually in a good position to turn it on. We don't need any valves or anything. We can just plug our speaker in there, turn it on and see what the hum's like. Here we go. Righty ho. Speakers in, power's in, standby is, we're on standby. It's off at the moment. I'll turn it on. I don't expect you to hear anything. You couldn't even hear it when it was humming, but I'll get the camera off the overhead in a moment. Let's turn it on. Here we go. I can't hear anything alarming. There is a hum there, but it's about 10% of what it was. Have a listen. I'm not even sure you'll be able to hear that. It's the most faintest of hums coming from the cab. So that is a result. What we'll do now is get I'm going to put a new set of JJ ECC83s in it and put the power valves back in, make sure it's all working after what we've done here. That's the first thing. Then I think I'll check the bias. I wonder if that's a bias pot there. That would be nice, wouldn't it? Right, I'm going to get 3 new 12AX7s. These are very old, the originals, and one of them was definitely microphonic and grumbling away. Okay, there we go. One. There we go, that's that. And yeah, we may as well put the power valves in. Ooh, yeah, okay. Ooh, that's tight there. That would have been annoying, wouldn't it? If after all that we hadn't been able to get that power valve in. That's really tight up against there. That's perfectly alright, but it's about 1/2 mil between the valve base and this. Would have just meant doing a bit of filing, but right, there we go. So we are in a position now to connect a guitar. Power light comes on, that's good. Very faint hum from the speaker. Out of standby, let's just make sure these are all at a sensible level. Okay, I can hear a nice reassuring noise. That's working fine, good. Excellent. The microphony is gone. Good. Before these valves get too hot, I'm going to turn off, and then we'll just quickly check the bias. Right, let's see what this is doing bias wise. Turn it on. Warming up, that's good. 450 volts HT. I haven't checked what the bias should be. This is looking certainly about right to me. I'll do a quick check on Weber bias calculator. Right, so it's looking almost exactly right to me, but anyway, let's just do a quick check. We have KT66s. Boom. We have 440 plate volts. And calculate bias. 39 milliamps, 37. I'm happy with that, not going to mess around. That's spot on, good. I was just about to finish off the job and I realised that we had this problem with this pot, if you remember, right from the beginning of this. Now, can you hear this? Don't be fooled into thinking that's a noisy pot. When you get a very even, all the way around the dial, exactly equal noise, so as you turn it, that's almost never a dirty pot, and that's a sign of having DC on the pot somewhere. You shouldn't have any DC on the pot, it should all be AC. And this has got some DC on it, I reckon. If you've got DC on a pot, as the wiper bumps along the microscopic track, you know, I'm obviously hugely exaggerating, as the wiper wipes around the track and it's got microscopic bumps in it, you're making and breaking that DC, and that produces an AC noise signal, which is what you're hearing there. So let's just see if this pot has indeed got DC on it, and then we can investigate why. Right, so go to chassis. What have we got here? Nothing there, that's probably ground anyway. Look, we've got 8 volts on the wiper, look, and 11 volts on here. So basically there's DC coming in here, and it's ending up, yeah, being affected by the track. It's this, what is this control? Looks like a treble control or something. Oh, presence, yeah. The reason I said it might be a treble control is because it's simply got a capacitor to ground and a resistor between there and there, so it's just dropping some of the high frequencies to ground as you turn it up. So this is the problem. We've got 10 volts, 11 volts DC here. Shouldn't be any DC. It comes into here, so there's our 11 volts there. There's a resistor going up to here. That's got 38 volts DC on there, going straight to a resistor to a pot. What rubbish design is that? That's absolutely pathetic. And that's where the feedback resistor goes in as well. So God knows what they're doing here. There are two possibilities here. One is just leave it alone. This is a presence pot, not the volume pot. It would be quite annoying if every time you turn the volume you got this. It's the presence pot. It's almost certainly going to be left in a particular position. are never changed, and so who cares if you adjust the presence a little bit, you get a very slight noise. The other thing I could do is to put a capacitor between here and here, and we might do that just for fun, you know, just because we can, and that would completely eliminate that DC. I'll do that just for your interest, nothing else. So just for fun, we're going to remove that. Right, we're just going to tack this in here temporarily. Like so. Now, according to my logic, that should kill the DC on the pot. Okay, the amp's alive and working, and ta-da! Not a peep out of that presence control. Let's just check the presence works. I knocked the volume there, let's just try that again. Yep, that works. I think I'm going to put that in. The customer will be watching this video, so if you're watching it, if you don't like the mod, just remove this capacitor and put that wire back onto the end there. So let's make that permanent. There you go, made that permanent now. So that's cured the DC on there. We are good to go. This amp is passed, and interesting little project. Well, there you go. Hope you enjoyed that one. Quite an interesting little project, and lots to learn there about how to chase hum with output transformers being in proximity to mains transformers. Pretty poor design, if you want my opinion on it. That output transformer was pretty much hard up against the mains transformer, asking for trouble. The DC on the pot, which we cured by putting a capacitor, is a pure design problem. There is literally DC on the pot by design, so that's absolutely terrible. We got it working, we sorted the hum, and on to the next one. Thanks as ever for watching, and we'll see you on the next video.